In the last video, I went over pointer declaration and pointer initialization. In this tutorial, I am going to cover call by address. But before I do that, I want to review a few quick things from the last video. So the process of declaring a pointer is just the data type, the unary operator, or the asterisk, and the pointer name. To initialize a pointer, you simply assign the address of a variable to them. So in this case, you can just say PTR, and to assign the address of a variable, you would need the address operator, which is just the ampersand, and the variable name. On line 14, when you print the variable, you're simply printing the data that the variable number is storing. And in this case, on line 6, the output will be 10. On line 13, when you print star PTR, this is also going to print 10. This right here, that is referred to as dereferencing. Not sure if I spelled that correctly. So in short, if you print PTR, you are printing the address of number. In order to print the value that the variable number is holding, or the data that the variable number is holding, you must dereference PTR by adding an asterisk in front of it. So this prints the data that is being stored in number. Now there is one more thing that I want to point out, and I'm going to type that into the code section here on the left. If you look at line 9, if I declare a pointer and not initialize it to anything, it would look like this. But if I do the star PTR equals 23, this will give us unusual behavior. One possibility is you may get a segfault because 23 is not an address. And so this pointer is not pointing to any location. A segfault occurs when a program tries to read or write on a memory that is not allocated to it, or an illegal memory. And in this case, that's not necessarily a bad thing. It's a way of the compiler protects the other memory locations, because we don't want our pointer variable accessing another memory block, which can affect the data of another variable that's being used for other functions. So on that note, what I want to do now is I want to first clear all the ink on the right hand side here on the red, and then I want to write a function that best demonstrates call by address. But before I write the function, let me go ahead and compile this real quick so we can see the behavior that's occurring on line 9 and 10. Okay, notice how it's given us unusual behavior. On line 14, we should be getting a return 0 here, but instead we're getting some weird negative number and an address. And that's because instead of segfaulting, we're accessing an address that we're not supposed to be accessing, or it's not letting us access it. The best way to understand call by address is to first understand call by value. And the best function to write when it comes to comparing call by value to call by address is a simple swap function. So here I'm going to create a function prototype for a call by value swap function. It's going to be a void data type, and I'm just going to call it swap value. And the parameters, I'm going to have two. I'm going to have num1 and num2 for the two integer values that we want to swap. And let me copy and paste this and put it down here. And so now let's create our definition for this function. So the algorithm for a swap function is just, first you declare an extra variable, and we'll call this temp. And then what we're going to do is we're going to set temp's value to whatever is stored in num1. And then we're going to store num2's value into num1. And finally, we're going to store the value that's being held by temp into num2. So let me just draw this on the right hand side to make sure that I coded the algorithm correctly. So here we have num1, and here we have num2, and here we have temp. So let me do the original. So let's just say we have 5 and 2. And here let me do the swap. On line 18, let's create a temp variable, which is here. And then we're going to store the value of num1 into temp. And then what we're going to do is we're going to store the value of num2, which is 2, into num1. And then on line 21, we're going to store the value of temp into num2. And there you have a swap function. Here, let me add a print statement. So now what I want to do is I want to go back to main, and I'm going to create two integer variables. And let's just call it a, and we'll set a to equal 5, and then int b will initialize b to 2, kind of like what we drew on the right hand side. And then we're going to call the swap value function, and we're going to use a and b as the argument. So now let me run it. But here's the question: did we really swap the values of a and b? So here in main, let me do a print statement. And let me add a new line here for formatting, and a new line here. And let me go ahead and print it. So notice in the swap function, the values were swapped, but when I printed a and b in the main function, a still holds the value of 5, and b still holds the value of 2. Although the numbers were swapped in the function, it wasn't swapped in main. The main reason is because the swap value is a copy. We passed a copy, and whatever changes we made only stayed as a copy, kind of like the Xerox analogy. All the changes that we made only affected the Xerox copy and not the book itself. So how do we make changes to our variables in main, a and b, to where we're actually making a change to actual book, like this picture here at the bottom, and not to the copy of the book pages, like the Xerox copy? The way we do that is by using a call by address function. A call by address function, the pointers allow us to pass the variable and not the copy. So let's write our function. So here on line 6, I'm going to write a function prototype for it, and we're going to call it swap address. And we're going to have the same variables, int num1 and int num2. I'm going to copy and paste this so I can write the function definition for it. But here's the difference. In swap value, we're passing copies. In swap address, and let me spell this correctly, in swap address, we're going to use pointers. So what does that mean? That means that pointers hold addresses. And so when we actually call the swap value, or in this case the swap address, and let me go ahead and change this, we're going to call the address, hence call by address. Let me add the pointers here. And so let's write a definition for this function. The algorithm is identical. The only difference is we're replacing num1 and num2 and changing them into pointer variables. And so we're still going to have a temp, and we're still going to store the value of num1 into temp. But notice how I have asterisk num1, because we're dereferencing that address so that we can have access to its data. After that, I'm going to assign the value in our dereference num2 into num1. And then finally, we're going to assign the value that temp is holding into num2. And I'm just going to keep our print function for a and b in main, and let me run this. Notice how the values are swapped. Notice how a, which used to hold the value of 5, is now holding the value of 2, and b, which used to hold the value of 2, is now holding the value of 5. So let me just trace this in a stack frame so that I can show what's happening in memory. On line 8, an activation record is created for main. And in main, we have two variables. We have a, and let's just say that has an address of 0x100. And we have b, and let's say that has an address of 0x200. And a holds the value of 5, and b holds the value of 2. And we also have two print statements in main. And I'll abbreviate that to P. And then on line 13, we call the swap address function. We actually call it before the print statement, so I'm just going to abbreviate that to SA. And so an activation record is created for SA. And so we jump to SA, and SA has two pointer variables. We have num1 and num2, and since they are pointers, they're holding, and let's just say, I'm going to put the address on top here. Let's just say this is address 0x300 and 0x400. These pointers are holding the address of variable A and B of main. 0x100, so this is pointing to that, and this holds 0x200, this is pointing to that. And so these pointers right here, kind of like the remote control, are able to modify our variables in the main scope or in the main function. And so it's able to swap 5 and 2. So 5, after we go through the algorithm, 5 becomes a 2 and 2 becomes a 5. And when you print it, you actually get A equals 2 and B equals 5. And so that's what's happening in memory. So in summary, this swap works because we are directly changing the value present at a particular address, the address of A and B, and the values gets reflected throughout the program and not just a particular function like the swap value. That's why A and B are swapped without getting any return values from the function swap address. And this is the power of pointers. Thank you for watching.